In today's solving basics for trig equations, let's look at the equation cosine theta equals 1. Now, when I see this equation, of course, it's a pretty simple trig equation, but that 1 really sends up a red flag to me as, hey, this is going to be one of those special type of angles. And we'll talk more about why. But anytime I see 1, -1, 0, I'm thinking, hey, that's right. Those are the angles that don't come from our special right triangles. So when solving this, I like to think which angle or angles have a cosine of 1. That's really going back to the root of it is finding exact values because we're looking at the cosine of some angle that equals 1. And we're just working in the opposite direction to try to find the angle here when solving. So here's our basic outline. We're just going to simplify it a little bit here because we recognize this to be one of those that probably has quadrantal angles or as their solution. And remember, all a quadrantal is an angle that has its terminal side on an axis. Again, it doesn't come from one of those special right triangles. So a simple overview here, we'll analyze, we'll find out, it says quadrants, but we're adjusting that to quadrantals. And we won't have to worry about a reference triangle, and then we'll just state our answers. So let's see how this works. So here's the word quadrantal spelled out, just in case you want to see it. Quadrantal. And those are angles that have terminal sides on the axes. And so to figure out which angle we're talking about here, all we need to do is remember that on the unit circle, the cosine of an angle is going to be the x-coordinate of the corresponding point. And so we're thinking about that unit circle. It has a radius of 1, and there's only one place where we have an x-coordinate of 1. Think about it, that's the horizontal movement of 1 unit. So working from the origin, moving 1 unit out, it must be this angle right here. And just to be sure we consider it, there's no other place where we have a positive 1 horizontal movement. So this is our only angle answer here. Again, we're skipping through. We don't have any reference triangles because we're dealing with a quadrantal angle as our answer. And now we're ready to go on to step 2. Let's state our angle answer. And we're first going to do this on the interval between 0 and 2 pi, or our answer on the unit circle. And this one's super easy. The terminal side is in that standard initial position. It's on the positive part of the x-axis. So we don't actually rotate away at all from that original position. So theta must be 0. Plug that back in just to double check. Yes, the cosine of 0 is 1. Note that we don't say 2 pi here, even though 2 pi is a solution. Because of how I wrote out this interval, it includes 0 but not 2 pi. We would say 0 is the only solution on this interval. Now say you wanted to solve this for all solutions. That's just a little different. We're going to use a solutions equation. So we'll say theta equals, we want to write 0 and all its coterminal angles. Remember, coterminal means it shares a terminal side. You just rotate differently to get there. So for example, getting to the terminal side in our sketch, say we rotated all the way around once in that counterclockwise direction, we know 2 pi would also be a solution to this equation. Or if you rotated another rotation, just sketching that in, 4 pi would also be a solution. So we're basically going to say 0 and all its coterminal angles, remembering that a full rotation is just 2 pi radians. So we can say 0 plus 2 pi k, where k is any integer. And depending on which one you substitute in, you'll get a different coterminal angle. You also could see theta equals just 2 pi k in this case. That would be a correct representation. I personally like this one just a little bit better because it works, you're able to apply it to other instances. It's just a good format, a good template to use. But this one would be correct as well. So whichever you like is completely fine. And that's all there is to solving this one. So hope that helped clear up some solving basics for this trig equation. And be sure to check out more worked examples from the links in the video description. Thanks for watching.